Okay, so now the final operation before we get into the customization is to cut the same angle of chamfer but on the back side of the hole. If I were to take the part off and flip it over and then do it, I'd introduce variance because there's human error and the part just wouldn't be as high quality. So what I'm doing is I'm using this dovetail cutter, go down below the hole, and then cut the same chamfer on the back side. It was pretty nerve-wracking learning how to cut a back chamfer because it's like your machine, so you can't even see. And you're having to blast lots of coolant down in there in order to keep the tool from getting clogged up with chips and breaking or overheating. This tool is very expensive. This is actually a $75 tool, and they last quite a while. They'll cut a lot of parts, but I had just swapped it out to do this final batch of custom thread locks, and I dropped the tool holder as I was going to measure off, so I programmed in the height offset. I dropped it and it broke the tool without cutting a single part. So that actually held up production completely because I only had the one. So I actually had to order another one and just wait for it to come in. But $75, 0 parts. It was a very, very frustrating morning. So now that I have machined the frames to this point, the next step is inspection. I need to make sure that all of the holes fit perfectly. And so to do that, I just take the bolt and I go through, I check the clearance hole, I check the threaded bolt hole, and then I take a pin and I check to make sure that the taper fits perfectly into the pinhole. Now that pinhole has been 3D machined to have an identical taper angle to the pin, but I need to actually confirm that nothing caused problems with that, because lots of things can go wrong. Chips can clog up and cause the dimensions to be off. So anyway, I'm going to check that and then also screw in the threads of the pin into the opposing frame, make sure that screws in nice and effortlessly. Then I'll remove the frames. So then I'll measure them, make sure they all conform to the tolerance requirements, and then they will be deburred, polished, and anodized, and then they'll go back on the machine to be engraved and have holes drilled and tapped for jewelry to be threaded in. So here we go. Okay, and then after all that, after the threads are cut, after the holes are cut, after the part is surfaced, and after all of the holes have had the corners cut off of them, that's when we go through with this spring-loaded diamond. It's a diamond tip on there. And so then this, actually, after I programmed the engraving file, which is a different engraving file for everything has to be done individually, but this will go down, press into the part, and drag around and cut the engraving design into it. So anyway, I've already got a part loaded up, or a pair of hooks that will become a custom pair that I have on order. So I figured I'd just show you these final processes, and then you can really see, the art and engineering come together, and create something pretty beautiful. Okay, so we've cut the frames now. So the final step with the stainless hooks is to bend them, and then they go through a vibratory tumbler for dry media polishing, which gives it that nice consistent shine. Much more consistent than hand buffing could achieve in a reasonable period of time. It does take longer. I can hand buff frames in, under 10 minutes and get them to a really nice shine. And this takes 24 hours. But it gives me extreme uniformity and allows me to process like 40 hooks at a time rather than just working one by one. Also, hand polishing is really messy, and so the frames have to go through an extensive cleaning process. With the titanium, there's no other option. To get the shine that I require to be really considered jewelry with the titanium and prep it for the anodizing, all has to be hand polished. And then it's thoroughly cleaned before the anodizing and degreased, and everything has to be perfect on the surface finish in order to get a perfect color with the anodizing. But anyway, I'm going to give you guys a look into this process. So anytime you bend metal, you leave marks on the material. There's no way around it. You're using something hard as a fulcrum to bend at that point. So there's lots of pressure. But with these, I want them to be as beautiful as possible and have as few like blemishes that are from the manufacturing as possible. And so I do that by actually manufacturing my own bender. I actually bought one off the shelf, which was very expensive. And then I threw it on the table of my mill and machined it to modify it to make this specific part. So this bender is actually made 100% specifically for the frames. But by doing that, I have almost no mark left on the inside, the point where it bends, and then the outside there's no mark at all because I use ball bearings on the dies that roll over the surface rather than rubbing, which is what normally happens with a lot of the 3-pin style benders. So anyway, the precision has to be exact, and that makes the bending process really my least favorite because it's the easiest to mess up, because it's a manual process, and if I screw it up, literally that frame is scrapped, and this is the last step of the process. So lots of time is wasted. But I threw them away, or rather I recycled them, but for a while I kept a bucket of scrapped frames, and when I turned it in, it was over 20 pounds of stainless steel frames. So it's really nerve-wracking setting a big piece of cast iron molding that's been surface grounded and everything perfectly for bending, and then just taking an end mill to it and cutting into it, because it was, essentially the most expensive piece of material I've ever worked on. I mean, because the entire thing is destroyed. Whereas sometimes with that larger piece of material, you can kind of recover it or use it for something else. But this would have been totally destroyed. Thankfully, I got it perfect. And this thing works great. But this is like my third or fourth design of a bender. The bending has gone through a lot of stages. It was extremely difficult to master. Bending stainless is very difficult because there's a process called work hardening that takes place with stainless steel. And that means whenever you cold form it, meaning you're not heating up the material and you're bending it, it actually causes hardening of the material at the point where the material is being displaced at the bend. And that means whenever you bend it, if it isn't right, you can't really rebend it because that part is really hard. And so it actually bends right next to that part. And that becomes essentially like the new fulcrum, that hard spot. And so anyway, this is just a huge process. And this stage has caused more scrapped frames than anything else. And just really, really, miserable days in the shop. I've destroyed an entire batch before of like 20 hooks. And you can see just the very minor marks left, which are a lot less visible after the polishing as well. It's a lot of hooks. There's more too. Some of them are already bagged up and complete. So this is officially the biggest batch I've ever made. But I mean, you guys have seen now how much work I've put into making these, designing these, and engineering the process for effectively producing them consistently. The variance between parts is extremely small, and it's taken just an unbelievable number of hours. And I wasn't a CNC machinist before suspension. It was the need for equipment that didn't exist that led me to start teaching myself this art form, this engineering field. Anyway, thanks for coming along with this video series, seeing just the process and everything.